So Professor Julia Steinberger researches ecological economics at the University of Lausanne in Switzerland, and her research examines the connections between resource use, energy and materials and greenhouse gas emissions, and societal performance, economic activity and human well-being. Since 2023, she co-leads the European ERC Synergy grant, REAL, a post-growth deal on post-growth societies. She is the lead author for the IPCC 6th Assessment Report with Working Group 3. Is Julia online? Hi, hello Julia. Very nice to welcome you here. So as a matter of fact, Julia was also super busy, so not able to join us with a train today because of a really busy agenda, but still she is here for delivering this interesting talk that I hope you will connect to. And she will probably try to also make a link with what we have been exposed to last week with respect to the theories of justice to define one scenario with respect to one theory of justice from the ethical standpoint, which is something that she researched also in her, or tried to include in her research from the future scenarios. So Julia, thank you very much already for being here today. Oh, I forgot to mention, so we were in English because the previous talk was in English, but if you, well, you can use the language that you prefer for your talk, being French or English.
Thanks, Nicolas. And it's really nice to be with you. Can you see my screen? Can you see the slides?
Yes, we can. Thank you very much.
Okay. And actually, I was given the choice of language, and they said, and if English is okay, that makes it a bit easier for me. But I can also understand French if people have questions in French. So I'm going to talk to you a little bit about I guess you're having a training on sustainability and technology as part of your study area at the École Polytechnique de Louvain. And so I thought I would try to orient this in terms of the role of technology for living well within planetary limits. And I'm looking at it especially from the perspective of energy consumption. So I'll start with something very basic, which motivates this research, which is that we're headed for a very bad place indeed. We're headed for cataclysm. So I'm an IPCC lead author, and I just want to share some of the basics from the latest IPCC report. I know that you've had some aspects on carbon emissions, for instance, but I just want to make it very clear that right now we're headed for a temperature of 3 degrees, more or less. By the end of the century. Right now, we're probably, 2023, we might have breached 1.5 degrees, just at least this 1 year. And this takes us outside of the Holocene temperature range. The Holocene temperature range, in technical terms, is where we were since the end of the last ice age, so about 12,000 years ago. And it's a very stable, warm temperature in which allowed humans to do everything like develop agriculture or cities or writing. And so technologically, all our technologies are based on the Holocene. That's one of the things to understand. And we are really not suited, especially in terms of agriculture and other aspects, for this rapidly changing, very hot planet. And we have left the Holocene in the last 10 years, as you can see on this plot. And I really think that this quote of Deborah Roberts, who's co-chair for Working Group 2, the next years are probably the most important in our history. This is really our history as a species. This is the largest challenge our species has ever faced. So we really need to take that seriously. I just want to remind you of some of the extreme events we've seen in the last year. So this was a weather pattern over Europe and North Africa that is basically due to the weakening of the jet stream. And what happens is that these domes, heat domes and low pressure domes sort of stay put. And what happens are things like this, just areas where it rains, several years worth of rain just in a couple of days. So for instance, this is the breadbasket of Greece. It's its main agricultural area, and that agricultural area is damaged forever. It will not recover to its previous productivity. This is obviously what the same weather pattern did in Libya across the Mediterranean. So, this is sort of what urban planning looks like in the era of climate impact, where you just have an entire city and tens of thousands of people killed overnight, basically. And this is another one from Mexico in Acapulco after a hurricane. And the thing to realize here is that, of course, we were used to associating hurricanes with Mexico, but this is a Mexico that made landfall on a major city on the west coast of Mexico. This is on the Pacific coast, where Mexico had never previously in our historical record been hit by a hurricane. So this is an absolutely new kind of cataclysm for that part of the world. So we have the scientific basis for the climate crisis. Basically, it's the 7 reports that constitute the previous IPCC assessment. So AR6 has 7 reports in it, 3 special reports, 3 working group reports, and then the synthesis. And they tell us sort of where we are, why it's happening, and where we're headed, and also what we can do about it. Now, I want to go very quickly into what we can do about it. Oh, no, sorry. I just wanted to make sure that to share some of the results. For instance, that we're able to predict not only climate very well, but also extreme events very well. So this is a result from Working Group 1 on the physical science. And I'm not going to go into detail into it. We don't have time today. But it tells us not just about average warming, but it tells us about, for instance, a 10-year event, how frequent a once-in-10-year event will be in the future, or once-in-50-year event will be in the future in terms of heat waves, for instance. Here we see that we can project the geographic impact of things like heat waves, extreme rainfall, and droughts. And they have different geographic signatures. So this is something that we can do. We can actually tell not just what the impacts will be, but where they will be happening geographically. Belgium is in an area that is touched by all 3 of these major categories of impacts, heat waves, extreme rainfalls, and droughts. So, despite the fact that we often think that in Western or Northern Europe we're safer, we actually are very much touched by these impacts. And in fact, we're one of the regions that is touched by all 3. We can say something about what these impacts mean in terms of severity. And one of the things that we are realizing is that the impacts are more severe than we used to think they were. So if you look at previous reports, the 5th assessment report, the 4th assessment report, you'll see that severe impacts are projected to happen at lower and lower temperatures, because scientifically we're catching up with the impacts and we're finding that the impacts are more severe at lower temperatures than they used to be. And I just want to point out this website, because I think it's often difficult to know how to communicate accurately. And this World Weather Attribution website is actually really good in terms of telling journalists, for instance, but also scientists, what it is possible to say in terms of climate impacts or not. So I really recommend this. The resources exist in all the European languages, and you can see how we can sort of explain what is happening because of climate change or not. Okay, so I'm sorry I went over that rather fast. It's to get to the more interesting stuff, but it's certainly the context of this research. Basically, when we're trying to do something about this, the mainstream way of looking at this problem is green growth. And there are lots of papers that are showing that green growth is not really happening. So this is just one of the more recent ones. Is green growth happening? An empirical analysis of achieved versus Paris-compliant CO2 to GDP decoupling in high-income countries by Efim Fogel and Jason Hickel. And they find that really it's not happening. So one of the things you can see on the figure is, so the idea of green growth is that the economy continues to grow, but emissions and environmental impacts go down. And here what we're seeing is that there are some countries, not all, where environmental impacts are going down, but in fact, they're not going down fast enough. So this is the sort of trajectory. The red curves are the trajectory of emissions decrease in the countries where they're decreasing, which are not very many. And then you can see the blue curves would be where these countries need to, with the curves that they need to be following if they were to achieve Paris-compliant fair emission reductions. So basically, right now, the few countries that are reducing their emissions and growing GDP are not doing it enough. And of course, lots of other countries are just growing their emissions. So one of the conclusions from this article is that basically we can't count on normal policies. We can't count on the framework that every single country has been trying to follow. This is inadequate for our moment. And so we really have to think about something very different. And so what they say is to achieve Paris-compliant emission reductions, high-income countries will need to pursue post-growth demand reduction strategies, reorienting the economy towards sufficiency, equity, and human well-being, while also accelerating technical change and efficiency improvements. And here you already see a lot of the different elements that we want to talk about today, and that also go to the conception of justice. So what is this justice that we're talking about here? Because we have these ideas of sufficiency, equity, human well-being. So let's talk about those. So basically, what does it mean to reorient the economy towards sufficiency, equity, and human well-being? So that's what we're going to be talking about for the rest of this talk. And I just want to start with some stylized facts on energy and well-being. So when we're trying to understand what the economy is doing or what our technological system is doing, we want to try to understand it in well-being terms, and it's really good to understand some basics. So I'm just going to tell you a few basic facts. The first basic fact is that there's basically a saturation effect. So here, it doesn't actually matter what the indicators are on these plots. They always look the same. But in this case, it shows the Human Development Index, which is a well-being indicator, versus on the vertical axis versus annual per capita electricity use on the horizontal axis. And I think the data is for the year 2000, maybe 1995, probably. It was published in 2000. And what you see is that at the low levels of energy use, you see that there's a very steep slope. So a little bit of energy will get you a potentially very long way in terms of Human Development Index, although there's a lot of spread, but that at high energy use, it just does not matter anymore. You know, there's a difference of a factor of 4 or 5 at the high level, and there is just no gain to be seen. So that's one of the things to really take very seriously is this very steep relationship. And for a long time, including in this paper by Pasternak, people believed that this was the development curve that countries followed, that they would go up along this curve, that if they increase their energy, then they would increase their human development. But it turns out that's not true. It turns out this relationship itself is changing very rapidly, and it's actually changing in the right direction. It means that countries are able to increase their human well-being without necessarily increasing their energy use. And so that's the second fact that is really important to understand, is that although this curve always sort of exists and always has the same shape, it's in different places. It changes where it is over time. So the energy threshold associated with any given level of well-being decreases dramatically over time. And this is what is shown in this figure, where you have energy use on the vertical axis versus time on the horizontal axis. And you see the energy, the dark green curve is the energy associated with high human development threshold. And you can see that it's just dropping over time. It used to be around 110 gigajoules per capita. It's now down around 40 gigajoules per capita. So this is just a very steady decline. And it's something that we continue to observe. So that also means that in the 70s, we had a supply problem, right? There was not enough. The average world energy use was around 65 gigajoules per capita. So that's really not enough. That's about half the energy necessary for high human development. Right now, that's completely changed. So we now have, before we used to have a supply problem, now we have a distribution problem. And that's also interesting to understand. The other point to understand is that there's quite a bit of diversity in countries that achieve high human well-being. So here it's measured as life expectancy on the vertical axis versus carbon emissions in tons per capita. Carbon emissions are just a measure of fossil fuel energy use. And you can see that there's quite a bit of diversity of countries with relatively high life expectancy, but relatively low carbon emissions, and that they come from basically all different continents, different kinds of geographic and political systems. The only countries that are not included there are, in fact, the yellow core OECD wealthy consumer countries, I would say. Okay, so that sort of tells us about some basics, but what we really need to do is we really need to understand what's going on beyond just understanding we throw energy into a country and we see what kind of well-being indicator comes out. So we want to go beyond that. And so for that, we needed a new research framework. And this is the analytic framework we used within the Living Well Within Limits project. So we have resource use. I'm just trying to think in your terms. I think it'll be on the left. So we have biophysical inputs on the left, which planetary processes and natural resource use. And on the right, we have social outcomes, need satisfiers, and well-being. And in the middle, what's interesting is that we chose to look at the whole middle part as provisioning systems to get away from mainstream economics. Basically, mainstream economics does not know how to understand this problem in an interesting way. So we decided to look at heterodox economics and provisioning systems, which have both physical and social aspects that we can study together. Okay, so I have a background in physics, you're engineers. We do not learn about well-being and we do not practice it necessarily very much. So this is one of the things that we had to understand better. And this is where we go into philosophy, because it turns out that some of the first people who really thought and wrote about well-being in a coherent way were Greek philosophers. And so this is what we do, is we go back and we read them and we try to understand what they were talking about and what their ideas have become. And this is one of the things we did within the Lily Project. So basically, first off, there's Aristotle around 350 before Christ. And his view was that well-being means to be able to live life as fully as possible and flourish within one's society. It's a very social view of well-being. And it's this idea of flourishing. It's the idea of having life chances, basically. How do you do the kinds of plans that you might want to have? Later on comes Epicure, and he had a very different view. It was a much more personal view, and his view was that well-being means achieving the most positive and least negative feelings possible. And the interesting thing is that these two camps exist to this day, okay? And you kind of have to choose whose team you're on to some extent. So what does this look like? And if you're on Team Epicure, by the way, philosophers really get upset by this slide, and they're right. It's a very strong simplification, but I think it's important to, it just helps communication. Oh, I'm really sorry. I just realized that my computer is not plugged in, so I will now go plug it in. Otherwise, it will die, and we will not have a conference anymore. So here we go. Okay, hopefully that will work. Okay, so if you're on Team Epicure, what happens? Your view of well-being is that it's happiness. It's so this very sort of emotional, personal perspective. It's very individual. You might measure it according to the happiness indicator, which is a real indicator that exists, or the utility value of utility in mainstream economics. And your view of the economy is pretty, this Epicure himself would not have agreed with this, but this is sort of what his ideas have turned into via mainstream economics, is that more income means more consumption, and consumption is how consumers get utility from the market. So the way you gain utility in mainstream economics is you go out into the market, you buy stuff, it makes you happier. So more income basically immediately means more happiness, more utility, more positive feelings. So economic growth is considered quite positively in this worldview, which is really our dominant worldview today. So Team Epicure is the winning team right now. If you're on Team Aristotle, your view of well-being is very different. You see it as flourishing. You see it as something that's social. Yes, you might measure it using something like the Human Development Index or the Sustainable Development Goals. These are both perspectives that have multiple indicators, multiple dimensions of human well-being. So you're not trying to measure it with just one indicator. You're trying to measure it with a whole bunch of different things that you might combine or not. And the view of the economy is very different. The view of the economy is that the economy is there to support human potential. So the economy is nothing by itself. It is only there in order to support human potential, in order to allow people to have life plans. That's basically what the economy should be doing. And as you can probably tell, within the Lily Project, we decided that we agreed mostly with Team Aristotle, and we wrote some papers on that, if you're interested. Now, the second point is, well, maybe we've gone and read some philosophy, but we're still empirical, quantitative scientists. We still really, really want to understand if this theory works or not. So we decided to test it. And the way we test it is we basically say, we try to test the theory of human need of Doyle and Guff, that was published in 1991. Where they basically said that well-being is achieved by a bunch of different human needs satisfiers. So you have these multidimensional need satisfiers, and once they're satisfied, you don't need more, but you have a chance at life. And so you should have well-being. And so we looked at this. So basically what we're trying to do is we're trying to look for empirical evidence that multidimensional need satisfaction is a precondition for well-being. And this was published in Nature Sustainability. It's work led by Dan O'Neill. So we had a bunch of countries, so most of the world countries, and we had a bunch of data. We looked at the number of need satisfiers they achieved, and we looked at their average need satisfaction from that. And you can basically see that the more need satisfiers a country achieves, the higher the life satisfaction. And so that basically looks like pretty strong evidence to us. We did not expect it to be at all so strong. It looks even stronger for healthy life expectancy. So healthy life expectancy is an indicator of physical health. And what you can see is that the relation with need satisfiers is even stronger, that basically because it saturates at a certain point. So basically that tells us that we think we're in a good road for this research, that we have good empirical evidence for our underlying theory. Now, I am not going to go into donut economics of Kate Raworth. I am just going to summarize some of our findings to motivate what we looked at afterwards. So this is a summary. This is the summary plot of this paper in Nature Sustainability in 2018. Basically, what we did is we looked at the number of biophysical boundaries a country transgressed. So basically planetary limits on the horizontal axis. And we looked at the number of social thresholds that those countries achieved on the vertical axis. And every time they transgressed another boundary, we moved them along the horizontal axis. Every time they achieved a social threshold, we moved them up the vertical axis. And you can see a country like France, which is probably not too dissimilar from Belgium. I'm not quite sure where Belgium is on this plot. Maybe it looks like it's not there. It might not have had enough data, but it would probably be very close by, is achieving a lot of social thresholds, but also destroying the planet, transgressing a lot of biophysical boundaries, whereas a country like Sri Lanka is achieving some social thresholds, but and not transgressing any planetary boundaries, but really not doing very well on the social front. And there are countries that are the worst of both worlds, that transgress a lot of planetary boundaries and don't have much to show for social progress. And the area that's very lonely, distinctly white in this plot, is where we need to be. And this means that we're all developing countries, and we all need to figure out how to achieve good social outcomes while remaining within planetary boundaries. And how do we do that? So where do we go from here? I'd like to propose 3 facts and 3 ways forward in the rest of the talk. So that basically 3 empirical things we can understand and build on, and 3 ways forward that we can really sort of explore as pathways that are promising. The facts are inequality, possibility, and dependency, and the ways forward are sufficiency, investment, and economic democracy. So the first fact is inequality. And I just want to show this plot because it's very illustrative of what we're talking about. It shows that carbon emissions are very unequally distributed. If we just look at the pie, the circles on the right of the plot, the top 1% richest part of the population is responsible for 15% of that pie of those emissions. The top 10%, which is purple and red together, are responsible for 48% of emissions. So this means that the top richest 10% of the world, which includes most of the population in Europe, are responsible for half of the global problem we have. Whereas the poorest half of humanity is represented by this tiny little green part here, which is 7% of emissions. So the poorest half of humanity is responsible for less than half of the emissions of the top 1%. This makes climate a hugely unequal problem, and it really matches economic inequality. It follows it very closely. What does this look like in a bit more detail? And this is a result from Marta Baltrushevitz and her, it's the paper that she published this January. And it shows the UK. The poorest decile is at the bottom. The richest decile is at the top. And you can see that, and then you have basically the energy footprint of the UK. And you can see that housing is remarkably equally distributed. This is the UK. The UK is kind of crazy. It would be different in Belgium, which is less crazy, or other countries of Europe. You would see an effect of income, but the effect is not that large, basically. Where you really see energy inequality taking off is literally in flights and car travel. So transportation modes are the ones where transportation categories are really the ones driving inequality in emissions and inequality in energy use. And that's true for one country like the UK, but we were able to show that it's true all over the world, in fact, that transport categories are really the most unequally distributed. In the UK, it's so bad that the richest 10% use more on flights than the poorest 20% do total. So it's really very shocking. And I think that this brings us back to the justice discussion. We have a large injustice built into this very unequal system. And what would be a way forward for this? Well, a way forward would be sufficiency. And sufficiency means that you avoid underconsumption and poverty, but you also avoid overconsumption and excess. So sufficiency is defined by Yamina Saheb and the IPCC as a set of measures and daily practices that avoid demand for energy, materials, land, and water while delivering human well-being for all within planetary boundaries. And what might it look like? Well, it might look like this housing cooperative in Geneva, so it's not very far from where I live. It's a very beautiful place, a lot of shared infrastructure, no cars whatsoever. It's actually just an amazingly wonderful place even to visit. So I think sufficiency can look very beautiful, actually. A very desirable way and place to live. The second fact is possibility. So we decided to model what a different future could look like, a model of a low energy and high well-being future, and see what that could look like. So this is a very first effort. It's based on Narasimha Rao's Decent Living Energy Framework. So he had this a sort of sister project, and he's now at the University of Yale. So we basically used some of his results and development of decent living energy to build this model. And his theory connects human needs to sufficient levels of energy services. And what our model took into account were things like demographic change, technology improvements, and we really tried to make distribution equal in the sense that everybody had access to the energy services sufficient to their needs. Not everybody the same level of energy services, but sufficient to their needs. And maybe this is another discussion to have in the context of your debates around justice. So I'll sort of skip over what the model looks like and takes into account. It takes into account a whole bunch of things. Maybe I can just say this is not a low-tech model. Everybody gets a phone, a mobile phone. Every household gets a computer. Everybody has internet. Everybody has data. Everybody has a washing and drying machine and a dishwasher and hot water and warm or cool, comfortable living spaces. We include private consumption, public consumption, so hot schools, hospitals. We include the infrastructure that goes with them. And and this is sort of in more detail what the energy services look like. But the main thing is our result, which is where I have this idea of possibility, is that decent living energy for all is possible in 2050 at 40% of current energy use, despite population growth. So the decent living energy is shown with a green arrow here. It's really far below where we are today, and it's far below where the International Energy Agency, the IEA, thinks we will be in 2050. So it's a really radically different future. It's based on efficient but realizable technologies. It's based on equitable shared infrastructures. And basically everybody's needs are satisfied, but nobody is living in any kind of luxury or overconsumption. but nobody is living in deprivation. That's what this model represents. And that brings me to the second way forward, which is investment. So this is possible, but it requires a lot of technology investment. And this is a really beautiful paper by Jarmo Kikstra from 2021 that I recommend to everybody. It's really amazing, where he and their colleague, they basically did the same kind of study we did, but then they went further and they decided to estimate how much energy would be required to get there. And they estimated it in energy terms. One could estimate it in material terms or in other kinds of resource terms, and monetary terms too. They estimated it in energy terms, where they showed that the shelter, the one would need 290 exajoules of investment, but the most of that is in the shelter sector, and a quarter of it maybe is in the mobility sector. And there's also regional disaggregation. And what you can see is that if we invest, it's a huge investment, it's massive, it's a major, major effort, right? I mean, for instance, for sub-Saharan Africa, it means building like really nice housing with lots of air conditioning for everybody, right? But once it's built, once we've made this super efficient, high quality housing, you can see that the annual energy use after investment for shelter goes way down. And that's because we have available existing technologies for housing not to use a lot of energy. And mobility requires a lot of investment too. Let's not kid ourselves here, but mobility afterwards would be the sort of half of the energy requirement, because there are no miracles in physics. Energy, you still need that much to move stuff around. The third fact I would like to talk about just before I finish, which is dependency. So what are we depending on? Why are we dependent on high energy or high resource use? What factors enable or disable societies from achieving well-being at low energy use? And this is where this idea of provisioning systems becomes very important, is to try to understand dependency. Provisioning systems are really the linchpin, the keystone between planetary boundaries and well-being. So we have to understand what these provisioning systems are doing. And basically, the third fact around dependency is that provisioning systems could enable good life at low resource use. I just showed you a model where we see this, but are often engineered to create resource dependency. So we have a theoretical possibility, but the reality is quite the reverse. The reality is that our provisioning systems are pushing us in a resource intensive direction, as you can see here with this American highway. The dependency on resource intensive consumption is itself, when you look at history, an industrial product. It's driven by decades of lobbying, subsidies, and state and regulatory capture. Basically, what this means is that industries like the automotive industry or the road industry or the petrol industry, all visible in this image, have been lobbying and convincing the American government and politicians to create conditions under which people can only drive big cars long distances, and that any other option is removed, as they paid to destroy public transportation, for instance. And this is something that we studied, and I recommend Julia Steinberger's article on a political economy of car dependency. I'm going to skip this. If you want my cartoon version of economics, we can talk about it. I'm going to skip this too. I just want to talk about this one. We helped Philip Alston, the UN Special Rapporteur on Extreme Poverty and Human Rights. He came to the UK in 2019. Our research was in the UK, and he asked us to help him out for his report on poverty in the UK. And we talked to him about, we basically provided to him our research on privatization of transportation, water, and electricity. And his conclusion, this is how his conclusion of our research showed up in the report: abandoning people to the private market in relation to services that affect every dimension of their basic well-being without guaranteeing their access to minimum standards is incompatible with human rights requirements. And I think we're seeing that play out in many parts of the world extremely tragically right now. The third way forward is democracy. So if we want to avoid dependency, if we want to get away from the state capture of these industries, we have to take control back over the economy. So we have to expand the scope of our democratic decision-making into the economy. We can't just say the invisible hand will take care of it. The invisible hand is destroying any chance we have of a reasonable future. And what this means is active economic citizenship through expanded decision-making roles of workers, community members, households, and multiple layers of governance. And this is something that we see democracy actually as being important. When we looked, this is a paper from Yefim Fogel in 2021, we looked for what factors that we could see in international databases that would enable some countries to live better at low energy use than others. And the positive factors were public services, healthcare, transportation, infrastructures, etc. Income equality, so equality is very important here. Democracy, also very important. Electricity and sanitation access are hugely important. So really access to public services and infrastructures effectively. And negative factors we also identified, including extractivism and economic growth above a moderate income. And extractivism we understand very well. The economic growth we were a bit more surprised about, but maybe not so much. And so basically we know if we had sort of knobs to turn in our model, what knobs would we want to increase? We'd want to increase the positive factors. What knobs do we want to decrease? We want to decrease the negative ones. And that tells us a bit what societies we want to go towards. Societies with excellent public services, much more equality, much more democracy, much less extractivism, and not focused on economic growth. Which brings us to the next piece of research I'm going to be doing. This is a project that just started, so we don't have results yet, on realizing a post-growth deal. And we're going to do a lot of things in there, a lot of different scenarios and modeling and more analysis. But I'm really excited that we're going to be looking at what it means to democratize the economy. That's one of the things I'm really excited about, and that's one of my roles in there. And I think that's it for me. I always end with this slide. I think that we should rethink our role as scientists. I think that as scientists, we are guardians of knowledge, and that means that we need to not just act as though business as usual is okay. It is most certainly not. We have to try to stop and raise the alert on what's happening, and that means joining popular movements, engaging in civil disobedience, and so on. Thank you so much.
Thank you.